So let me give an idea like this: T1 greater than T2 greater than T3. All of a sudden I'm asking, it can happen. So I want the temperature of junction. Find the temperature of the junction. So what we do, let the thermal power flow like this: H1, H2, and let it be H3. Or sir, finding very difficult, sir. I'm nothing flashing for me. Okay, you do one thing. Take like this. So what is the temperature? T1, T2, T3, R1, R2, R3. So the heat current here, H1, H2, H3. So what is the temperature of junction? So therefore, what is H? H is equal to H1 plus H2 equal to H3. What is this, sir? How you are writing this one? What is the meaning of this? Anybody? What is the meaning of this? I know method, sir. H1 plus H3 equal to H3. What is the meaning of this?
Kirchhoff's laws and Kirchhoff's laws was there now, sir.
Okay, you mean to say Kirchhoff's law. Okay, fine, yeah. But these are not current, no?
Heat flow gets added up, sir.
Not getting? Yeah, Gunetra, something.
Sir, heat flow gets added up, sir.
Heat flow gets added up. No, still,
Heat current.
Still, I want better answer.
Sir, due to 1 and 2 temperature difference, the heat also flows in 3, sir.
No, still I want better. Still I
Sir,
want
due
better.
to difference in T and T3, sir.
I know that. I know that. I know. Heat coming is going out, sir. Okay, Gayatri, what is that? Heat coming is going out. I just want your response, sir. Oh, you do
The
one thing.
net heat retained in the junction is 0, sir.
Okay, or you do one thing. We'll go for water. 10 liter per second, 8 liter per second. How much should come here? 18 liter per second. 10 liter, 8 liter, here you get 15 liter. What do you mean by that? 3 liter per second got leaked up. Or 10 liter, 8 liter, I'll get here 20 liter. Then 2 liter per second, from where it has come, we don't know. So therefore, what is the thing? What is this H1? It's a thermal power, energy flowing per second. So therefore, at a given junction, the net flow of heat should be 0. Means how much of thermal energy per second is entering, that much of thermal energy per second should leave. Otherwise, energy output will be created or will be destroyed. Should not happen. So this is nothing but, shall I say, law of conservation of energy principle. Simple methodology. Amount of heat entering a junction per second should be equal to amount of heat leaving a junction per second, or conservation of energy principle. This is nothing but, don't call Kirchhoff's law because we don't have anything like that. So still, since we know Kirchhoff's law, okay, we'll try to equate here. So here I'll put it like at junction. Where is the junction? There's a junction. Huh? There's a junction. So at junction, amount of heat entering a junction per second should be equal to amount of heat leaving a junction per second. So what are the thermal powers that are entering? H1 plus H2, and the one which is leaving H3. What is H1? We'll write it because it will flow from high to low temperature. So therefore T1 minus T by R1. Then T2 minus T by R2. Then T minus T3 by R3. Solving for T, we'll get the required answer. We know length L1, L2, or I'll do one thing. I'll make a little bit easier. No? 2L, L, L by 2. Okay, we'll have values like this. It'll be easy for us. Okay, let's substitute all. Okay, we'll see what is the, we'll get it. So T1 minus T. What is R1? R1 is 2L by KE. T2 minus T2. R2 equal to L by 2KE. R3 will be L by 2 by 3KE. Okay, L by KA gets eliminated. So 2, so this will be T1 minus T by 2. This will be 2. Three by 2. Solving this, we'll get the required answer. Okay, T1 by T2. T2 plus, this should be equal to T by 2 plus 2T plus 3T by 2. This will be 4T. 4T, and this will be T1 plus 4T2 plus by 8. Is I'm okay? Check the calculation once. This will be temperature of junction. Okay, now few will get a doubt, sir. How you decide that? Why can't you write H1 plus H3 as H2? You see this T1 greater than T2 means why can't let it be like this? Huh? H1 plus H3 equal to H2. I think you look at the temperature of these two are greater than this. So definitely we are just assuming the heat will flow here. You solve it means because what about this one? If T greater than T3, then the heat will flow here. If T greater than T2, then the heat will flow here. Then you change the direction of current, no problem. Heat current. Sir, are you sure that H2 will be like this? I'm not sure. I'll calculate the value of T. If this T greater than T2, in fact, H2 will flow. No problem. Just we took algebraic sum here. Okay, like that, if you have more than 2 rods, okay, there's a method what we apply to get the temperature of at any given junction. Okay, it's all about now current density ideas. Huh? I don't know, teachers should not prefer to ask questions, but in weekend exams, no, rather than the core thermal conduction problems, no, the teacher will get deviated questions of these kind. May not, okay, this is similar to current density. Huh? They'll try to drag you to more current density ideas. So, okay, let me discuss few so that will be on better position. Let's take the next one.